Yes. Now we are going to learn about characteristics of enzyme catalysis. The first one is most highly efficient. What is the meaning of most highly efficient? That is, one molecule of an enzyme may transform 1 million molecules of the reactant per unit time. 1 million molecule of the reactant per unit time. For example, H2O2 hydrogen peroxide decomposes to give H2O and O2 and balancing 2H2O2 to H2O. For this reaction, the activation energy is 18 kilocalorie per mole without a catalyst. Without a catalyst, the activation energy is 18 kilocalorie per mole. But with colloidal platinum, the activation energy is 11.7 kilocalorie per mole. But with enzyme catalyst, the activation energy is less than 2 kilocalorie per mole. So it is most highly efficient. The second one is highly specific in nature. One catalyst cannot catalyze more than one reaction. For example, urea, NH2CO, NH2 urea on hydrolysis in the presence of an enzyme urease forming ammonia and water molecule is released, 2 molecules of ammonia. But same urease cannot catalyze the following reaction of methylurea, NH2CO, NHCH3 plus water. This urease, when we are applying, no reaction takes place. So, one catalyst cannot catalyze more than one reaction. Third one is highly active under optimum temperature. What is meant by optimum temperature? The temperature at which enzyme activity is high is called optimum temperature. So, optimum temperature for enzymatic catalyst activity is 298 to 310 Kelvin. Human body temperature being 310 Kelvin or 27 degrees Celsius or 98 degree Fahrenheit. So this temperature 310 Kelvin is this temperature suited for enzyme catalyst reaction. If you are drawing the graph, rate of reaction, temperature, this is the optimum temperature, highest temperature. At this temperature only the enzymatic activity is opted. Fourth point, highly active under optimum pH. Optimum, maximum, optimum. That's maximum at a pH called optimum pH between the values 5 to 7. Next, catalytic activity of enzymes increased by a small non-protein vitamin called a coenzyme. And activators such as Na plus, Mn2 plus, CO2 plus, Cu2 plus metals. So enzyme amylase in presence of sodium chloride catalytically is very active. Next, the last one, sixth one, influence of inhibitors and poisons or poison. Inhibitor means can increase the activity of the catalyst. Penicillin inhibit action of bacteria used for curing diseases like pneumonia, dysentery, cholera and other infectious diseases. Poison means activity of an enzyme is decreased, destroyed by a poison. Destroyed by a poison. So what is the mechanism of enzyme catalysis? How will you explain the mechanism? First, there are a number of cavities present on the surface of enzymes. These cavities are of characteristic shape and possesses active groups such as NH2, COOH, SH, OH, etc. These are called active centers on the surface of enzymes. Now the reactant molecules or substrate which have the complementary shape fit into the cavities just like a key fits into a lock. For example, enzyme. Consider this is the enzyme, substrate. Substrate, that is the reactant, giving an activated complex. Activated complex. This breaks into, once more the enzyme is got, plus products. Products are got. On account of the activated groups, the activated complex is formed which decomposes to yield the products. So in step 1, enzyme combines with the substrate forming an activated complex. This activated complex decomposes to give once more the enzyme plus products get released. This is the mechanism of enzyme catalysis. 2 steps: enzyme combining with the substrate forming an activated complex. The enzyme should fit into the substrate just like the lock and the key. Both should have the complementary shape. So it fit into the substrate forming an activated complex. Then it divides into enzyme and once more the products get released. This is the mechanism of enzymatic catalyst.